Hey everyone, my name is Alex Shibu. I'm from Toronto, Canada, and this is my grandpa Joseph. My grandpa is a coffee farmer in the southern part of India. And each time after the monsoon season hits, I could see firsthand the challenges he faces with coffee leaf rust, a disease that is widely happening, especially in the southern parts of India. And it's not just my grandpa. Over 150,000 smallholder farmers in India who control over 600 acres of Arabian coffee farming are facing this issue alone. And my goal with this presentation is to bring light to this problem and to propose a solution that I'm uniquely able to do. So currently when coffee leaf rust hits, damage goes all the way up to 70%, with around the average peaking at 40-45 depending on the season. And that leaves almost 1.8 billion rupees in lost revenue each year, only specifically in Wynad alone, that is mainly farming coffee. And for buyers who are willing to pay almost 18 rupees per kilo, for these is left on the table. 18 rupees, global buyers are willing to pay extra for a non-moisture, like there's a bit more moisture that comes into the coffee after this. And the status quo of the solution takes, you go in and blanket spray with pesticides, which costs 800 lakhs per acre. And the cost, so this means the cost of blanket spraying the acre, the pesticides used, and it means more money spent and worse quality of coffee. Then also the other solution is having a worker go in and scout these leaves and when specifically it's changing. And the cost of that is also super expensive per acre, and they are not able to cover enough ground per day. They're only able to cover 0.5 acres per day. And the existing model we're stuck in is this, where coffee leaf rust starts small, then it impacts the yield the farmers have every year. That causes farmers to have lower income, and that causes them to skip the next year's pesticides used to prevent the loop of increasing coffee leaf rust. And our goal with this project is to use precision drones and embedded systems to reduce the yield loss to under 10%, use 80% less chemicals, and have zero worker exposure, especially in Wynad and stuff. These slopes are set up in really hilly, over 30-degree angles, and that caused year by year, I think it's up 12% the last time I checked. And in terms of, okay, this is like a bit of an old slide, but in terms of what we've been doing so far is we're using current, the text is all weird. In terms of what we've been doing so far, I've been building custom drones and developing a YOLO V8 deep learning model to identify leaf rust like this. And so my goal is to put it on drones, then just fly, and it's able to identify leaf rust like this and deliver precision sprays that solve this problem. And currently I'm going to India right after this, so Sunday I'll be going to India to validate my problem with farmers, because this is me sitting in Canada researching and maybe talking to my grandpa, uncles, and all these things, but I want to be on the ground piloting this over the next, I'll be there for 4 weeks. Then the other thing is that the government currently, our main advantage is that the government is currently subsidizing over 75% of drone purchases, agriculture, modern, emerging tech purchases. So that's something we'll be able to leverage to deliver it to the market. I think that's pretty much it. Thank you so much. Our ask mainly is to connect with farmers to really pilot the product. That's our main goal right now. And yeah, thank you so much.
I actually have a question just about this last slide. So if you go back one, it says 70 interactions by phone.
Yeah, so
Can you tell us a little bit more about that part of the?
Yeah, so a lot of the current, so how the market is distributed, especially in further and out rural places, is that most of the interactions either happen in person or by phone. It's not through the internet or like web resources. So our goal is to deliver heat. So after we do the precision monitoring of the where exactly the problem is spreading, offer heat maps of where exactly the problem is starting through phone and things like that. And yeah, that's pretty much what's going on.
Well, I mean, how exciting
Yeah,
that you've
super
got
exciting.
these
Yeah.
drones and you're about to pilot this. It
Yeah.
sounds super exciting. And you may not have already thought about, business model or anything, to advance when you're just testing it.
It's like a passion that I wanted to like make it useful, so I was like, yeah.
Good for you.
Yeah.
Good for you. It sounds like it will be useful. I am curious about whether you eventually see the farmers themselves using the drones, whether you see like a team going out. How are you seeing this concept?
So there's a problem in the southern part of India specifically where youth are moving to either other parts of like
Yes.
urban India or out of the country for work because
Yeah.
like you don't make enough work. So the plan ideally is to equip young youth to fly these drones and also use these drones as a service.
Okay.
So instead of the farmers themselves having to buy drones
Yeah.
and operate them themselves, our goal would be to equip youth, or they could buy it or subsidize it through organizations on the ground, then have youth operate these drones, and farmers, instead of paying scouts to go on the ground and check acres of coffee, they would equip these drones, which is much less costlier for them, significantly. Yeah.
Okay, so farmers are already having, they're
Scouts,
already paying
or just
scouts.
spraying widely. So it's
Okay.
either one of two solutions.
Okay,
Yeah. Or they themselves go in and check it. Depends on how big the farm is. Yeah.
okay.
So thanks, what a fun sounding project, and so nice that there's a family connection.
Yeah.
That's really cool. Yeah, I guess what I'm thinking about is obviously the business side of it. So I'm guessing, on the one side there's the drone as a service, i.e., youth empowerment, giving people access to the technology and training them so that they can become service providers to the local farmers, right?
Yeah.
Okay. Yeah, I mean, it would be good, while you're in the field,
Yeah.
to try and maybe dimension what those costs look like. Like, how much would people be willing to pay? What are they currently paying on pesticides? What does a 75% cost reduction actually mean
Yeah.
in real lakh terms?
Yeah.
In which case, what would it cost?
Mm-hmm.
So that's the one part. The other part, I guess, is you have to convince the farmers ultimately that this is going to work.
Yeah. Instead of like their it's like you're saying AI is gonna be accurate. Like so, the model right now I'm working with is like we pushed it to like 80-85% accuracy.
Mhm.
So and that still means we have to fly lower and make sure all these different things. But yeah, convincing them adoption is a really challenge.
Yeah, so that adoption piece for me is kind of, really important, and to be able to ground truth that with some sort of farmers that are going to give you some space to experiment on, I think is
That's ideal.
that would be super, super helpful. So could you say a little bit more about the second step? So I get the first part around identification. So then the second piece is also a drone delivered, sort of pinpointed pesticide delivery.
Yeah, so the first piece is diagnostics.
Yeah.
Then the second portion of it is precision spraying.
Mhm.
So that part, diagnostics is the massive spend that I was thinking of focusing on in the beginning, where then you could just go specifically where it is and spray it. But also in the future, I hopefully I could run a test on this like next year, where I've seen versions of this in Brazil that's already using things like this, especially in research, where you could use the existing pesticide sprays or like a modified version of it through drones. And I guess you're pretty much hooking up like an industrial drone to like a pipe, and it's just going around and precision spraying it.
Yeah. Because that's where the value is delivered.
Yeah, that's where the value is delivered. The diagnostics itself maybe might not seem like there's like Yeah.
It helps you identify the problem, but the value for the farmer is going to be, instead of spending $100,
Yeah.
it's now $20 because I'm doing the precision piece.
Yeah.
So, you know,
Yeah.
I have a question about the equipment
Yeah.
and repair.
Yeah.
Because in other models, you know, equipment has been given to different communities and then, you know, breaks, something
Yeah.
small breaks, and then the piece of plastic
Yeah.
equipment is just sitting there because no one actually knows how to repair it.
Yeah.
Have you thought about that at all?
So specifically, I don't know how big of a problem that is, because last time I was in India, there is more a growing youth movement in like emerging technology.
Yes.
So I fixed my drone in India last time I was there, and there's a existing infrastructure. But what I want to look at is it possible to like set up local communities in some hubs in like with either training or with some, or like make sure there's somebody who could fix drones. So there's like a geographical places where people could go to like fix the drones if they wanted to. Yeah.
maybe just two quick other thoughts. So value added services that you, because you're in there flying at low
Yeah.
level, what else can you do? So, you know, I don't know, soil temperature, soil moisture,
Yeah.
what other agronomic data
Yeah.
points can you grab while you're there that's going to add value?
Yeah.
Because, yeah, that's where you can pack in. So,
Yeah.
question mark, you know.
Extra value prop, because we don't really have much cost for the other things we could add. It's like it's already running the vision models, right? So it doesn't. Yeah.
Yeah, and then sort of, I guess, you know, laying that in with, if you've got a large learning model with local weather.
Yeah.
So that kind of, I guess there's an interplay there that's going to tell you, you've got a likelihood of this thing
Personalized
outgrowing because
suggestions.
it's a-
Yeah.
Yeah, which is, I guess with the value, I mean, I've seen a lot of progress in this precision farming space. There's a lot of, progress. The idea of making it low cost and accessible, I guess that's where the win is. The query around equipment,
Yeah.
the sustainability of the equipment on the ground is interesting. I saw a rehabilitation program for a coastal wetland area where they were using drones, and they had actually built a team of people that were printing all the drone components on site in a remote location. So I could maybe
Wow.
add that link here if we do
Yeah.
that, you know, and they were really going the full hog in terms of empowering
Yeah.
local people with the
Yeah.
capacity to build,
The
assemble,
downs. Yeah.
and doing the full, you know, because they were relying on the drones for their work, and they
Yeah.
needed to be able to have a team of people on site to do it.
Yeah. I haven't thought about like the downstream and all the different places where we could like make it
Yeah.
like a regenerative sort of business model. So yeah.
Yeah, fantastic.
Yeah.
Yeah. Thank you so much for thank you.